Good afternoon, class. Today we are going over a word problem that explores probability. This is a concept that we have gone over before, so you should be familiar with this type of question. The question we will be working on today is a statistics instructor tracks the calls and texts that he receives on his cell phone over a month. Using this data for a randomly selected message, we will find the probability that it came from a family member. Then we will find the probability that it is a phone call that is a wrong number, the probability that it is a text message or a scam artist, the probability it is a family member contacting him, given that he received a text message, and determine if the events receives a text message and is contacted by a family member are independent. We are going to do this step by step. First, we need to start by collecting the totals of each row in the graph. If we add together phone calls across, we get a total of 36. And we can do the same thing for text messages, adding across, and we get 24. And now we can go down the columns and get 15 for family members, 14 for opinion surveys, 21 for scam artists, and 10 for wrong number. 36 plus 24 is 60. These also should add up to 60, and that's how we know all the numbers are right. We can do a quick check. And yes, they add up to 60, so all our totals are correct. Now let's move on to the probability questions. The first question we need to answer is, what is the probability that it came from a family member? We are looking to find the total amount of calls from family members. So we are going to divide the total messages from family members from the total of messages. We're going to set this up as P of F. We get 15 over 60. But we need to simplify to find the least common factor. 60 can be divided by 15. And it can be divided into it 4 times, so it becomes 1/4. And if we divide 1 by 4, we're going to get 0.25. Remember that all probabilities cannot be over 1, and 0.25 is not, so it fits the criteria for our answer. Next, we must calculate the probability that it is a phone call that is the wrong number. What we are looking for is the probability that it is a phone call and the wrong number. To first set up this equation, we are going to use the equation for P, A, and B. This equation is PB over PA. So our equation is going to look like P and W. And it's going to be PW over PP. Our variable for PW is going to be 6 because it is the number of wrong phone calls. And our variable for PP is going to be 60 because it is the total number of messages. So this is going to look like 6 over 60, which is going to simplify to 1 over 10, which is 0.10 as our final answer. Our next question is, what is the probability that it is a text message or a scam artist? The key word in this problem is or, because it tells us what equation we need to use. This equation is PA plus PB minus PA and B. So let's set up our own equation, which is going to be P, T, or S, we're going to get our variables from the chart. So PT is going to be 24, and we're going to put 24 over 60 because we need the probability of text as a whole. And then we are going to get 21 as S because it is the total number of scam artists. We are also going to put this over 60. And then we are going to subtract the text messages and scam artists, which is going to be 8 because that is text from a scam artist. And we are also putting this over 60. Now, it is a common mistake to forget to subtract P and S. But it is important because you don't want to count this number twice because we're already getting it through these. So that's why we need to subtract it. Now, if we add up 24 over 60 plus 21 over 60, we get 45 over 60. Still subtracting 8 over 60, and we get 37 over 60, which then simplifies to 0.6167 as our final answer. Next, we will be solving for the probability that it is a family member contacting him given he received a message. After reading this problem, can you find a key word that would help give us a formula to solve this probability? This keyword would be given. Using the formula for given, we should get an equation that looks like PF given T. And that is P, T, and F over P of F. If you look at the chart, can you find any variables you would think would go in for P and F? So, P and F is going to be 8 because it is text from family members. And if you remember from before, we are going to put 8 over 60, and we're going to divide it by P of F, and P of F is going to be 24 because it is the total number of text messages. Just like before, we're going to put it over 60. And with a little key change flip, we're going to get 8 over 60 times 60 over 24. We can cancel the 60s out. And 8 goes into 24 3 times, so we're going to get 1/3. And 1/3 equals 0.3 repeating as our final answer. The last problem we need to solve is to find if the event receives a text message and is contacted by a family member are independent and why. First, let's go over what it means to be independent. Two events are independent if the occurrence of one event does not affect the chances of the other even occurring. Two independents are independent if and only if P, A, and B equals PA times PB. So what we are looking for is if receiving a text message and a message coming from a family member affects the chances of each occurring. To set up this equation, we are going to find if PT and F equals PT times PF. First, let's find out what PT and F equals. So it is going to be 8 over 60, which simplifies to 2 over 15, which is 0.1333 repeating. Now let's solve for PT and PF. PT is going to be 24 over 60, and PF is going to equal 15 over 60. Now we're going to want to multiply these two. We can cancel a few things out. 15 goes into 60 4 times. And we can cancel out 24 and 60 to 4 and 10. So it's going to be 1 times 1 to 10, which equals 0.10. And now let's set up our equation. So 0.1333 equaling 0.1, which is not correct. They do not equal each other. So this means that they are not independent.